Preview.
Many of the raw ingredients used for manufacturing in the chemicals industry are petrochemicals based on crude oil. As a finite resource, this causes a number of problems for the chemicals industry. The cost and supply of oil can fluctuate greatly, and the geopolitics of sourcing oil adds further uncertainty for the manufacture of chemicals based on oil.
Preview.
At the University of Bath, we're investigating some innovative technologies in an interdisciplinary project to convert terpenes into useful chemical raw materials for the chemicals industry. Terpenes are a highly abundant class of natural product that in fact we're all very familiar with anyway. They're available in citrus oils and oil of turpentine and in pine oils. And in fact they've been used since antiquity in flavours and fragrances. In this large research project we'll be looking at various facets of taking terpenes from raw materials right through to part of the manufacturing process. In the first part of this project, we'll be looking at the catalytic technologies that we might employ in converting the terpene raw materials into useful chemicals that can be used in the chemicals industry.
Terpenes are available mainly as waste products from the wood processing industry. So at the moment they are available in relatively large quantities. But if we can develop a new chemical industry based on terpenes as precursors, then those supplies will run out, and it wouldn't really be practical to grow pine forests just to make turpentine. So our part of the project is to try and persuade bacteria to turn their natural terpene supplies into some of the more useful terpenes that we'll use as chemical precursors.
In parallel with developing the chemistry, we're also going to develop the chemical engineering of these processes.
Normally what happens is that the chemists develop different transformations, and then that is transferred into the engineering department where we scale up the whole process. In this project what we are going to do is we are going to work together from day one. In this way we will be able to integrate engineering aspects into all the scientific development in order to scale up the process in a very short period of time of 5 years.
In another facet of the project, we're also looking at some of the pathways to manufacture that can then feed back into the scientific developments that we're making. So we're going to be interested in looking at the supply chain issues that might arise from using a renewable rather than a petrochemical feedstock. We're going to be looking at some of the economic and environmental drivers that again will feed back into the development of the science, and hopefully as a whole will generate something that can be taken up by industry relatively easily. We're actually really excited about this project because we believe we can have some really significant impacts fairly early on in the project. The chemistry using industries are hugely important to the UK's economic base. Something like 21% of UK GDP is generated by the chemistry using industries, and that's billions of pounds a year. There is no doubt that in 20 years' time, the global chemical industry will be heavily reliant on biological and renewable resources rather than the petrochemical raw materials that they're using today. And it's really exciting to think that Terpenes and the University of Bath and our collaborators will be right at the forefront of that revolution in the chemical industry.
Shockwave Sound.